Hi, this is Group 2, and this is our design proposal for the MEC 203 final project. We call it the QUADERANG. The goal of this project was to provide a quadcopter drone toy that is attractive to kids and adults alike. Attractive to kids because of its toy appearance, familiar shape. It also features a customizable decal on the front. In this case, we made it the Seawolf. Go Seawolves, but you can make it whatever you want. The shape was inspired by the once popular kids toy, the Quad Boomerang. If you haven't seen it before, this is what it looks like. It looks pretty cool. It's aerodynamic. Before we get into the details of our design, I'd like to show you some drones currently on the market. So you can see here, this one's about $250. The cheapest they go is around $200, ones with cameras anyway. And the good ones are around $300 to $500, so they're pretty expensive. Ours, on the other hand, we estimate the cost to be around $160 to $200. This was achieved by making it mostly of cheap but somewhat durable plastic. And it also features some interchangeable parts, which is not a feature of the more expensive drones. So that was achieved by having some interference fits between the legs and the runners and the legs and the base. So in the event of damage, you can kind of just pull it apart and theoretically just buy one of the pieces instead of having to buy the whole new thing. With current drones on the market, if it gets damaged, you're pretty much just going to have to buy a whole new one, so that's an incentive for the consumer to buy ours. Ours also features a fully rotatable camera arm that can fit something about the size of a GoPro. So without further ado, let's get into the details of the design.
So if we look back to the base part, we will see that the base has a very aerodynamic shape that features a lot of cutouts, and the cutouts will decrease the total material used and minimize the cost. The inside of this part also features a compartment to house electronics. On top of the base, we see the space for 4 micro motors that will power the wings. The drill holes in the base of the motor are 1.1 inches in diameter with a tolerance of 0.01 inches. This will create a clearance fit with the simplified micro motor, which is seen here, which has a diameter of 1 inch and a tolerance of 0.01 inches. These motors would be made of various metals in the final production with increased complexity, and the clearance fit between the two parts allows the motors to spin freely. This motor shaft will have an interference fit with the wings, which are seen here, and to make sure that the two parts rotate together. The wings have a hole in the center, which is seen here, which will have a diameter of 0.95 inches and a tolerance of 0.01 inches. The wings also feature a curved surface, which is right here, to make sure that there's increased aerodynamic lift. The shaft of the motor will also be topped with a plastic topper that will be put together with an interference fit. This is a 0.97 inch diameter hole with a 0.01 inch tolerance. On the underside of the base, we see a large drill hole with a 1.6 diameter hole and a 0.02 inch tolerance. This is to have a clearance fit with the motor that will turn the camera arm a full 360 degrees. This shaft has a 1.5 inch diameter and a tolerance of 0.01 inches. Between this pin and the camera arm, which is seen here, there will be an interference fit, so this radius is 1.4 inches and a tolerance of 0.01 inches. This makes sure that the camera arm will not fall off during flight. If we go back to the base, we see that there are 4 shafts on the undersides, which are seen here, that have a ability to press fit the legs onto them. These have a 0.75 inch diameter and a tolerance of 0.01 inches. This gives us the interchangeable parts that we were saying is in our final design. These legs are seen right here and have an outer radius of 1 inch and will be fit into some runners on the bottom, which a P7H6 interference fit in a base size of 1. These runners will also have a P7H6 interference fit with rubber stoppers and a base size of 1.2 inches to absorb any impacts. This is the 1.12 inch diameter hole and the P7H6 location. To see the final animation in motion, thank you very much, and we hope you enjoyed our quadcopter.